What you've all been waiting for, mesh current. Yay. Okay, these are our guys. So let's see. This is already in the frequency domain. This is minus J8. This is 12 ohms. This is J4 ohms. This is minus J4 ohms. Okay, this voltage source is 20 angle 90. So it's 20. It's like, if you want to draw the phasor, you know, it looks like that. It's 90 degrees, which is straight up and has a length of 20. This guy here is 5 angles 0 degrees. This is amps. This is volts. This is, if you wanted to draw the phasor here, it's, so this, if you put it in rectangular form, it's going to be 5 plus J0, which is just 5, like this way. This one here, if you put it in rectangular form, it's going to be 0 plus J20, which is just this J. J is up. The J components are up and down, or vertical, and the real components are horizontal. Okay, we're asked to find I sub G phasor, which is, where's that thing? That's it's the current through, I sub G is the current through this, voltage source, I sub G. Okay, so using mesh current, specifically using mesh current. So we need to identify our mesh currents. So this one here is already given, so that's going to be I sub G mesh current. Might as well use the same notation as this guy. So, like, you know, there's mesh currents and there's branch currents, right? Through just this section of wire right here, they're the same. You know, IG branch is the same as IG mesh, just through this part here. But over here, you know, the branch current is not the same as the mesh current. Anyway, we've got our mesh currents. There's one. Let's choose one here, and this is actually given. If we agree with this, it's just 5. I mean, this is just 5. The J component is not there, so this is 5. It's known. This one here, let's go, we could go either way. We'll go ahead and, you know, go that way and call it I sub A phasor. All right, so what is the mesh current method? It's going to be V and IZ terms now, and these are all phasors. And we're going to use superposition, right? Where you do the effects due to the mesh current, and then you add or subtract the effects of the shared elements, right? So, so mesh I sub A, let's just see how many we need. We'll need at least I sub G. We'll need this one because that's what we're solving for. I sub G might be able to get by with just I sub G and this one. maybe, or we might be able to get by with, who knows. Let's just write I sub g first and see what that looks like. So I sub g, this guy going around here. So you've got the 12 and the 4. So it's an IZ term, right? So it's going to be 12 plus J4 I sub G. This is an IZ term for the 12 and the 12 ohm resistor and the J4 inductor. That's the voltage drop across the inductor and the resistor. Then we need this voltage drop in here. So it's just J20. You know, you don't really need the 0 plus, right? So this is the circle guy, right? And this is these guys here. This is Ohm's law. And this is the primary, right? What I call the primary loop. Then we need the superposition, right? Then we got the shared elements. So this guy, the J4 is shared. It's going to be 5 times J4, the current times the impedance, and it's going to be negative because the loop currents disagree. So it's negative. So this is the superposition thing for the 5 amp guy, and then this guy, the 12. So that's going to be 12 I sub A. This is superposition for the I sub A term, right? And once again, do they agree or do they disagree? The current. So this one, the current's going, IA is going to the left and IG is going to the right. So they disagree. So it's negative. And those sum to 0. That's mesh IA. So what do I got? I got IG is an unknown, and this one here should be IA, and IA is unknown. So I need another equation. So let's do mesh. Let's just do mesh IA and see if that gives me 2 equations, 2 unknowns. Because right now I have 1 equation and 1 unknown. So okay, mesh I sub A. This one here. So the primary effects are the 12, the minus J8, and the minus J4. So it's going to be 12 minus J8 minus J4, and then by Ohm's law times IA. These are the primary, the primary IA loop. And then superposition. I've got the minus J8 times 5, and it's negative because IA and IG are in opposite directions through this element. So this is superposition again. Superposition from the 5 amp. Yeah, and then I've got the 12. So this is going to be 12 I sub G. And I sub G is opposite direction. I sub G is going to the right, and I sub A is going to the left, so it's opposite. So this is superposition from the IG term, and these sum to 0. So I have 2 equations and 2 unknowns, IA and IG. So there should be a solution in here somewhere. So the rest is just getting your calculator to be able to help you out with this thing. So we can put this in standard form. So the IA equation, this one, it's 12 minus J12 IA, just getting it, IA, IG constants, so, and minus 12 IG, that's and then moving this thing here is just minus j, or positive j40, but then you move it to the other side and it's minus j40. So that's the first, that's the IA equation in standard form. And the IG equation in standard form is we want IA first, so minus 12 IA. Then the IG terms are 12 plus J4 IG equals 0. Let's see, this is that should be a 20. This positive J20 cancels this minus J20, so those guys go away, and you just got the 12, and then these guys, yeah. So that's that, and now your calculator may be able to solve this format. Heck, it might even be able to solve this format. It's different for every calculator. I can show you what it looks like on mine. So on mine, I set up these constants as a two-dimensional matrix. So this guy here becomes 0 minus J40, and this guy, just to get it to go into my calculator, it's 0 minus J0. Okay, it's a 2 by 1, or is it a 2 by 1 matrix, or maybe it's a 1 by 2, but it's 2 rows and 1 column. And then these 4 coefficients here, this one, this one, this one, this one, become a 2 by 2 matrix. So this thing here is 12 minus J12. And this guy here, you got to expand it. I do anyway to get it in my calculator. It's going to be minus 12, minus J0. And this guy here is going to be minus 12 minus J0 also. And this guy here is 12 and plus J4. Okay, so I have to set it up as complex numbers. And then I actually enter these with commas. This would be 0, comma J40, 0, comma J0. Now your calculator may be different, but figure out how your calculator does this. Read the instructions. Okay, I hope what I'm doing is in general helpful, but like I say, it's going to depend on how your calculator works. Anyway, in my calculator, this matrix here is given by these two matrices, and so I punch these guys in. I punch this matrix in, I punch this matrix in, I hit the divide button. Your results may differ, and I end up with these two. The answer, 4.66 minus 0.66J and 4 minus 2J. So this is I sub G here. So I sub G is 4 minus 2J, and that's the answer. You could put it in rectangular if you want, by punching another button on your calculator, and 4 minus 2J, or 4.47 angle minus 26.57. That's mesh current.